In this example video, I'm actually going to do two examples, both relating to circles. One is going to be to write an equation, and the other is to take an equation and give important information about it. So in the first example here, you can see we're going to write the equation of a circle when being given important information about that circle. And we're going to write two different equations, one in standard form and the other in general form. And these are two different forms that you can see a circle written in. Please review that information in the text, as I will just be proceeding through this example. So standard form for a circle, typically standard form is a lot easier than general form, so we're going to start with that one. So standard form of the equation of a circle is x minus h squared plus y minus k squared equals r squared, where hk are coordinates of the center and r is the radius. So all I have to do is simply substitute in the values given to me. So I have x minus 0 squared plus y minus 1 squared equals 2 squared. And again, this is standard form. Right? Now I can simplify this equation just a little bit. X minus 0 is really just x, and that's being squared, plus the quantity y minus 1 squared, and then 2 squared is 4. Now this is as far as I can simplify this equation if it's going to remain in standard form. So what's nice about doing it in this order is that to get from standard form to general form, all you have to do is actually multiply out this quantity, gather up like terms, all on the left-hand side, 0 on the right, and that's going to be general form. So we'll do that right now. Okay, so remember that when you're simplifying, what you want to do is execute order of operations to eliminate any grouping symbols, and then also combine like terms. So x squared is already multiplied out and everything. Y minus 1 squared, remember, is the quantity multiplied by itself, equals 4. So I'm going to use the distributive property or the FOIL method to multiply this out to get y squared minus 2y plus 1. Okay, so now what I want to do is combine my like terms all on the left-hand side of the equation. So I will subtract 4 from both sides to leave 0 on the right-hand side. Positive 1 and negative 4 are like terms. And now here is the equation for this circle in general form. Okay, so in the second example, I'll actually show you how to convert back from this form to the other. So now in this second example, I've given you various equations of circles, and we're going to identify the center and radius of each of these. So the first two examples here, part A and B, I've given you the equation in standard form. And again, we like standard form because it's very easy to see the important information. So let's actually, for part A, x squared plus y squared equals 4. What I'm going to do is rewrite this so it's a little more obvious as to what the center and radius are. So remember, standard form is x minus the x coordinate squared, y minus the y coordinate squared, and the radius squared. But this equation has to match this one. So x squared is really the same as x minus 0 squared. Y squared is the same as y minus 0 squared, and 4 is 2 squared. And now it's a lot easier to see that the center has coordinates 0, 0, and that the radius is 2. The radius is the base over here. Now in the second example, I'm going to do the same thing. The left-hand side is already looking pretty good, but the right-hand side needs to be rewritten as something squared, and 9 is 3 squared. So now it's really obvious that the center of this circle is 3, -1, and the radius is 3. Remember, if I take this section right here, in standard form, it's always y minus the y coordinate squared. Here we have y plus 1, and y plus 1 is really the same as y minus a -1, hence the y coordinate of the center being negative. Okay. So in this third example, or rather part C of this example, I've given you the equation in general form. And the downside to general form is that finding the center and radius is a little bit more work. So what I'm going to do is convert from general form to standard form so that I can identify the center and radius just like we did in parts A and B. So the way that we convert from standard form to general form is by completing the square. So remember how to complete the square. And since we have x variables and y variables, we're actually going to need to complete the square for each of those separately. So what I'm going to do is rewrite my general form right now before I start completing the square. And the way that I rewrite this is to group up the x's, group up the y's, and leave spaces for me to complete the square. So x squared minus 2x plus a blank. Then I have y squared minus 4y plus a blank. Equals, I'm going to take the constant term and add it to both sides, so I get a positive 4 over here, and plus 2 more blanks. So the plus blanks are all about completing the square. I've just set myself up here. Remember, when you are completing the square, that the quantity you want to add, I'll write this down here, is b over 2 squared. Okay, so -2 over 2 squared, but what you add to one side, you must add to the other. And then with the y's, I'm going to have -4 over 2 squared. And what you add to one side, you must add to the other. So we've added this to complete the square for the x's, and we've added this to complete the square on the y's. So this is a note here about completing the square. I'm going to continue my work down here. I'm going to simplify the quantity inside of the parentheses. That is a -1. And over here, that is a -2. Same numbers over here. Now that I've added this strategic quantity, this entire expression factors into a perfect square. And that's going to be x, because this is in the variable x, minus 1. Plus, again, we've completed the square, so this now factors into a perfect square. This has everything to do with variable y, and then minus 2. And then what I need to do over here is actually combine these values together. So -1 squared is positive 1, and -2 squared is positive 4. So I have x minus 1 squared plus y minus 2 squared equals 9. So now this is in standard form. And when the equation for your circle is in standard form, it's very easy to see the center has coordinates 1, 2, and the radius is not 9, but 3.